What if I told you that the Wi-Fi signal bringing you this video is made of the exact same stuff as the X-ray a doctor uses to see your bones? I know, it sounds impossible. One is just invisible data floating through the air, and the other is a powerful medical beam, but they share a fundamental secret, and once you see it, you'll have a totally new understanding of the invisible world that's all around us. Section 1. The conceptual barrier. Okay, let's just get this out of the way. How is this even possible? You've got Wi-Fi, which feels harmless, right? It connects your phone to the internet, streams your shows, and it's just there. It feels like air. Then you've got X-rays. You go to a hospital, and the technician literally stands behind a lead wall to fire up a big, intimidating machine. We think of X-rays for seeing broken bones, for airport security, and we know there's a certain level of danger involved. So one is for sending cat videos, the other is for seeing through things. They seem like complete opposites, but this is where our intuition about the world lets us down. To connect the dots, we need to talk about the hero of our story, the electromagnetic spectrum. Don't worry, it sounds way more complicated than it is. Think of it as one big family of energy, and all the members are related. Once you meet the family, you'll see how everything from your phone to the sun is speaking the same secret language. Section 2. The foundational concept, waves of energy. So what is an electromagnetic wave? The best way to picture it is to imagine a long rope tied to a doorknob. If you stand back and gently flick your wrist, you create a slow rolling wave. But if you flick your wrist fast and hard, you get a bunch of short, choppy, energetic waves. That's pretty much it. All electromagnetic radiation is just energy moving through space. And all of it, whether it's the radio signal in your car or the light from a distant star, travels at the exact same speed, the speed of light. But just like with the rope, the waves can be long and lazy, or they can be short and powerful. We measure this with two ideas, wavelength and frequency. Wavelength is just the distance from the top of one wave to the top of the next. That slow flick of the rope that has a long wavelength. Frequency is how many of those waves pass by a single spot every second. That series of fast flicks, that has a high frequency. Now, here's the golden rule. The one thing you need to remember, the shorter the wave, the higher the frequency, and the higher the frequency, the more energy it carries. Low frequency, low energy. High frequency, high energy. This is the key that unlocks everything. Section 3. The journey along the spectrum. The electromagnetic spectrum is simply the entire lineup of these waves, arranged by their energy. There are no sharp dividing lines. It all just blends together like a rainbow. Let's start at the low energy end, with the long, lazy waves. This is the world of radio waves. These can be massive, ranging from the size of a building to miles long. Because they have such low frequency and energy, they're perfect for communication. They travel huge distances and pass through walls without a problem. This is home to your AM and FM radio, TV broadcasts, and air traffic control. And you guessed it, Wi-Fi. Your Wi-Fi router is basically a mini radio station. It encodes internet data onto radio waves that your devices can read. Now, as we move up the spectrum just a little, the waves get shorter and more energetic. We get to microwaves. Yes, the kind that heat up your leftovers by making water molecules vibrate like crazy. But this part of the spectrum is also used for GPS, weather, radar, and your cell phone talking to the nearest tower. In fact, Wi-Fi technically operates in this microwave band, which is really just a high-frequency type of radio wave. Keep moving up and we find infrared. We feel infrared every single day as heat, the warmth from a campfire, a stove burner, even your own body heat. That is all infrared radiation. It is also what your TV remote uses to change the channel and what night vision goggles use to see in the dark. And right here, in the middle of our journey, we arrive at a tiny sliver of the spectrum that we are intimately familiar with. If you're finding it fascinating to uncover this hidden world, take a second to subscribe and hit that notification bell. We dive into big scientific ideas like this every week, and you won't want to miss what's next. Section 4. The spectrum continued. Right, past infrared, we hit a tiny sliver of the spectrum that we happen to know very well, visible light. This incredibly narrow window is the only part our eyes ever evolved to see. It contains every color you've ever experienced. From the longest visible wavelengths we see as red to the shortest we see as violet. A rainbow? That's just the sunlight being split into all its different wavelengths. It's a beautiful daily reminder that the spectrum is real. But just remember, the entire world of color is just a tiny fraction of what's actually out there. Because as we go past violet, we cross a very important line. The waves get shorter, the frequency gets higher, and suddenly they have enough energy to start messing with atoms. Welcome to ultraviolet, or UV, light, coming from the sun. This is the stuff that gives you a sunburn. It packs enough punch to damage the DNA in your skin cells. That's why we wear sunscreen. But it's not all bad. Our bodies use a little UV to make vitamin D, and we use it to sterilize equipment. Alright, now let's crank the energy way up. The waves get incredibly short, the frequency skyrockets, and we finally arrive at the other end of our journey. X-rays. These waves are so small, they're measured on the scale of a single atom, and with that tiny wavelength comes immense energy. Because they are so energetic, X-ray photons can do something radio waves and visible light can't. They can blast right through less dense things. So when a doctor X-rays your arm, the beam goes through your skin and muscle, but it gets absorbed by your dense bones. That's what creates the white shadow on the film, giving us a perfect picture of your skeleton. Section 5. The climax. The connection revealed. So, let's put it all together. We started with the gentle radio waves that carry Wi-Fi, and we ended with the powerful X-rays that see through skin, and the connection should now be clear. The only real difference between your Wi-Fi signal and the medical X-ray is the amount of energy each wave is carrying. They aren't different kinds of things. They are both just electromagnetic radiation, streams of massless particles, called photons, all traveling at the speed of light. A Wi-Fi photon is just a very low energy version of an X-ray photon. Think of it like a tiny ripple in a pond versus a 100-foot tsunami. They both just waves in the water, but they exist at a completely different and incomparable energy levels. This energy difference is why we separate radiation into two groups. The low energy end, radio waves, microwaves, visible light, is called non-ionizing radiation. Its photons don't have enough juice to knock electrons off your atoms, which is why Wi-Fi is safe. The most it can do is create a tiny bit of heat. But once you cross that line into UV, X-rays, and the even more powerful gamma rays, you're in the world of ionizing radiation. These photons do have enough energy to strip electrons from atoms, which can damage your DNA. That's why exposure to them is so carefully controlled by professionals. Conclusion. So, the next time you log on to Wi-Fi, take a second to remember what's actually happening. You're using one end of a vast, invisible spectrum of energy. And the next time you see an X-ray image, know that you're just looking at the other high-energy end of that very same spectrum. From the radio waves that connect the globe to the infrared that lets us feel heat, to that little slice of visible light our eyes can see, all the way up to the X-rays that save lives, it's all the same thing, just with different amounts of energy. It's an entire world hidden in plain sight that powers our technology and reveals the secrets of the universe. Seeing this connection doesn't just explain how your router works, it fundamentally changes how you see the invisible reality we're all swimming in every day. If you found this trip across the spectrum fascinating, do us a favor and hit a like button and share it with someone else you think would be amazed. And check out our other videos where we tackle more of the incredible science that defines our world. Thanks for watching.